Hey guys, Penny's gonna join us for a little while. We'll see how long she sticks around. If you see cat tail or cat face in the video, that's what she's just saying hi. Um, so I'm home for the second day today with a sick kid. So obviously video recordings are not ideal. Um, but at least now I know how to do them, and you are used to watching them and taking notes over them, and we'll just make the best out of what we're given. Okay, so we're gonna kind of switch gears today, and we're gonna go into some subatomic particles. We'll put what we're doing last week on hold, and we will get to that whenever I get back, hopefully soon. But for now, we're going to move on. Okay, so subatomic particles. This stuff should not be new information to you. Okay, you should be fairly familiar with protons, neutrons, and electrons. Okay, but I want you to make this chart in your notes, and you can pause the video right now. Pause it. Write this stuff down. And when you hit play again, we'll talk about it. Okay. Okay, so this column right here is pretty much standard knowledge. You should know that a proton has a positive charge, electron has a negative charge, and a neutron is neutral. Okay, that should be, basic middle school science information that you should hopefully remember. This stuff over here in this column is probably not middle school science, but it's pretty simple. Okay, so protons and neutrons both have a mass of approximately 1 AMU, and AMU stands for atomic mass unit. And basically that's just an arbitrary unit. You don't really need to know what an AMU is, but just know that it's a unit. Okay, so protons and neutrons both have a mass of about 1, and electrons have a mass of about 0. Okay, obviously it's not exactly 0 because an electron is actually it is something, so it has a mass. It's just a very, very small mass that we consider negligible when we count mass. Okay, protons and neutrons located in the nucleus. Electrons are located in the electron cloud. And this column right here is important because protons are going to determine the identity of that element. Okay, the number of protons an element has determines what element that atom is. Okay, electrons determine the reactivity. Okay, number of electrons in the electron cloud is going to dictate how reactive these atoms are. And a neutron is important because as we get to, and when we get to talk about nuclear chemistry, large sized nuclei can be very unstable, and so neutrons help to hold atoms together, basically. Okay, so looking here quickly at the mass, we can determine that the protons and the neutrons are the only thing that contribute to an atom's mass. And as we move forward here, that's going to be an important idea for us to have a grasp on. Protons and neutrons are the only thing that contribute to the mass of an atom. Okay, so here we go with atomic number and protons. The number of protons determines the identity of the atom. We talked about it on the previous slide. The number of protons is also the element's atomic number. So if you are looking at, and you probably should, either split screen or have a paper copy of a periodic table or something with you, the number of protons in an atom is that element's atomic number. And the atomic number oh, there goes the cat. The atomic number is the whole number that's listed in the box for your, or on your periodic table. It's the whole number, okay? Hey, there we go. It's next bullet point. In a neutral atom, so an atom that does not have a charge, in a neutral atom, the number of protons is equal to the number of electrons. Okay, so that would make sense. If I have 6 positive charges, if this is going to be a neutral atom, I would also need 6 negative charges, and so that's going to be my protons and my electrons. Okay, so that just kind of makes sense. So there is a specific way that we can write these atomic symbols. Okay, so mass number is going to be the sum of the protons and the neutrons. Remember that the protons and the neutrons are the only thing that contribute to the mass of an element or an atom. Okay, so it would make sense that if we're trying to calculate the mass number, we're adding together protons and neutrons. Okay, this is always going to be the larger number, and that would make sense. We're going to add these two things together here, so it makes sense that this number is going to be larger. Most of the time on the periodic table, this number is going to contain a decimal. Okay, not always. When you get down into the really, really big atoms, it doesn't always contain a decimal, but in the common atoms, it does contain a decimal. Okay. Then we look here at the, so this atomic symbol is looking over here at this notation. X is going to be the element symbol, so this would be like H for hydrogen, O for oxygen, Na for sodium, so on and so forth. Okay, and then the A up here, this is the mass number. So this number up here is going to be protons plus neutrons. Okay, that's my bigger number, protons plus neutrons. Z down here is just my atomic number, or the number of protons. Okay, so when you see a notation like this, or maybe you get asked to provide this type of notation, now you know where these numbers come from. This is the symbol. A is protons plus neutrons, and Z is just simply the number of protons. Okay, so here's an example. We got sodium, so we know that based on the element symbol Na. The mass number is 23. Okay, so that means I have 23 protons and neutrons added together. My atomic number is 11, okay, which tells me that I have 11 protons, and all sodium atoms, always, ever, in the history of time, all sodium atoms have 11 protons. Okay, if you have more protons, you are no longer sodium. If you have less protons, you're not sodium anymore. Okay, so all sodium atoms have 11 protons forever. And from this information, we can answer these two questions. How many neutrons does this atom have? And we can answer this by knowing this 23 and the 11. Okay, so we know that the mass number is protons plus neutrons, and I know the amount of protons I have. So what do I need to add to 11 to get to 23? 12. Okay, 11 protons plus X, if we're doing some algebra, X number of neutrons is going to be equal to 23. Bada bing, bada boom, I get to 12 neutrons. Okay, and then for electrons, I'm going to assume, because it doesn't tell me any differently, I'm going to assume that this is a neutral atom. And because it's a neutral atom, this is going to have 11 electrons, because electrons is going to be the same number as protons. Okay? Pause this. Answer these questions. How many protons do the following atoms contain? you're just going to look on your periodic table and identify the atomic number or the number of protons for each of these elements. Okay, pause it, write this down, answer them. Here's your answers. Okay, these are all the whole numbers on your periodic table for each element. Okay, this is the atomic number or the number of protons. Now I want you to basically do the opposite. I'm going to give you a number, once they stop spinning, give you a number, and then you tell me what the element is that goes with this number of protons. Okay, so now go find these numbers and identify the elements. Pause the video, go. Here we go with number 32 being germanium, 7 is nitrogen, 45 is rhodium, 13 is aluminum, and 92 is uranium. Okay, that is pretty simple chemistry, but it's very important chemistry in terms of being able to read the periodic table and understand the information that's being presented to us. Okay, that's one thing in chemistry class that we need to come away with. One skill that we need to come away with is being able to read the periodic table accurately. Okay, here's a couple more practice questions. Pause the video, answer these. So here we go, here's your answers. The mass number, iron, you should be able to identify the number of protons based on iron. Add 29 neutrons and you get to 55 for a mass number. Atomic number of nitrogen, this is just going to be some extra information that you don't even need to know. You're looking for the atomic number of nitrogen and it's going to be 7. Mass number of potassium, there's your number of protons, here's your number of neutrons, add those together, you get to 40. How many electrons does a boron atom have? Again, this is just extra information. We don't care about the neutrons right now. Boron being neutral, 5 protons, 5 electrons. Okay. I'm going to end with this. I want you to write this down, some information about isotopes. So isotopes are atoms with the same number of protons, but different numbers of neutrons. Okay. So in this case, we have sodium. Both of these atoms have 11 protons, but they have a different number of neutrons. These two things would be considered isotopes of each other. Okay, your worksheet is going to deal with isotopes. I'm going to make myself bigger so I can talk to you. But with this isotope worksheet, what I want you to do, you don't know this information. Okay, so this worksheet is kind of stepping you through this. It's new information to you. All right, so if you don't understand it, it's okay. If you don't know the answer off the top of your head, it's okay. Work through it, read the worksheet, understand what it's telling you. It's a 3 or 4 page worksheet, I think. If you have questions, skip it, move on. Ask me questions when I get back to school, when we get back in class, because that's what we're going to use some of that end time for. Okay? So don't just give up if you don't know the information or don't know the answer. Work through it, skip it if you need to, and continue to move on. I want you to open the worksheet in Kami, make your notations and your answers just like you always do. Do not open it as a Google Doc because it messes up the formatting. Okay? Just stick with Kami. All right? That worksheet's posted on Classroom as well. Let's get on it. See ya.